Hi there, my name is Sasha, and today I'm going to be talking to you about sentiment analysis with restaurant reviews. Now, before we jump into this, let's talk about the why. Now, if businesses had a tool that automated both the reading of and the gauging of the sentiment of things like customer reviews or even social media comments, then they would be better equipped to better understand their customers, specifically what customers want out of their experiences. Now, the dataset that I used was originally published by Yelp and contains about over 200,000 reviews about various businesses throughout Arizona. I specifically wanted to focus on restaurants because dining experiences can be hard to quantify. Like on top of the price of a meal, there are things like the ambiance, the customer service, the view, the overall vibe. And I wanted to see if machine learning had a role in uncovering some of these elusive qualities. Now, after filtering out, I was left with about 160,000 restaurant reviews with 5 classes, these classes being the 1 to 5 star ratings. And we can see here on the left that we had quite a class imbalance, with the majority of users rating restaurants 4 or more stars. So I consolidated these 5 classes actually into 3, into good, bad, and neutral reviews. So I decided to actually undersample my training set because of this class imbalance, and as you can see here, it resulted in some massive overfitting. Just to note that these scores are precision scores, and the baseline was established with random guessing, if each class had equal probability of being guessed. So looking at the scores for logistic, random forest, and gradient boosting, we can see that basically all of the training sets outperform the testing significantly. Additionally, the testing scores are akin to the baseline scores, which is random guessing. So I decided to not undersample and just feed my entire raw data set into some of these models. And additionally, I decided to use an ARIA and a recurrent neural network running an LSTM model to better capture the sequential nature of my text. So this round, the overfitting was not as much of an issue, except for in the case of the LSTM model, even though it is the best performing. So taking a closer look at the LSTM model, we can see that just after 2 epochs, the test performance starts to plateau. The confusion matrix on the right, with 3 being a good review and 1 being a bad review, we can see that the actually good reviews were indeed predicted to be good reviews. However, the model is generally predicting good reviews. So next steps, how do we increase model performance? Well, we need to prevent overfitting, and these are just some ideas to do so in no particular order. One would be to minimize the feature space without minimizing the data, so performing some kind of feature decomposition so that the models won't fit the data points so granularly. Another thing is that I need to find a more optimal way to address the class imbalance. Obviously, undersampling, resulted in some massive overfitting, but not sampling resulted in some rampant overfitting as well in the LSTM model. And the problem with the LSTM model could also be prevented by tweaking the RNN architecture, hyper-tuning the learning rate and the batch size to give the LSTM model more time to learn. Thank you very much. You can reach me in any of these platforms. I look forward to hearing.